Hello, this is Stephen O'Sullivan, and I'm presenting on database management systems today. So, introduction. How would you save tons of information that doesn't relate to one another? The solution, create different software for each type of information. And this is what database management systems is. Okay, so what is a database management system? Database management system is a system that puts different inputs and values that come into your company, such as like data and all that stuff, all from purchases and selling, and puts it all into different um, groups and groupings. What are the different types? There's two main types. There's SQL and NoSQL, and we'll get into how they're used in 1 minute. Okay, what is a database model? Database models were made to as structures to handle data because data comes in many forms, and you want a model that works and sorts out all the data into different pockets equally and efficiently. Most common type of database models, relational database models, and we'll go into what that is. Relational model is most commonly used model and replace hierarchy-based networks, databases, and it's called a relational model because it placed a relation on each input. So every input was related to something else, and that connects all the data to each other. And this gives way to the relational database management system that we're going to talk about today, or SQL system. Most common database management systems used related relational database management systems, or SQL, and then no SQL database systems, or new SQL. Okay, so no SQL. It's based on a relational model. It's also that type of storage. It uses SQL, which is structured query language, which is a language that allows software to organize data into different tables using schemas. Schemas are basically just grids, and it just puts them all into an order. And the SQL, structured query language, recognizes what you're looking for and what you want, and puts them into these different tables or schemas. Started of SQL model was in the 1970s and 80s when they first were getting all of the data. I guess first big data burst back in the 1970s and 80s with all of the computers. So that was the first wave of data, like you said. It was based on algorithms. So they would come up with a formula, and then that formula would look for anything that fit into that formula and put it into a different schema or table than all the other data. And as you can see, the data life cycle. Implementation was in the 70s and 80s, and it's still in use today. Of course, it's been refined and worked and reused and re-upped. However, it still stays to its base of using SQL to organize into separate subcategories, and basically, like you see on the right, create a tree. Problems with the relational model is that the schema struggles with the rise in data. So as there's more and more data becoming available, there's more and more different types of data becoming available, and it costs a lot, and takes a lot of time for to get the right language from the SQL to recognize all of those. And it's not as quick or powerful as it once was with all this new data. And it's getting more expensive and outdated, which basically means SQL, there's a lot of softwares out there that don't use it, and they're cheaper, and they use cheaper products, and SQL does not do that generally. So new SQL or no SQL, it's a dynamic model schema where you can come up with whatever way of tabling you want. You don't have to follow a specific system. It's agile and dynamic, much more so than the regular SQL model. And it was made in 2000 to keep up with the new wave of data that was coming in. Um, all this different from like barcodes and um, shipping and the internet, like the way the internet progressed, so did all the data. So it needed to keep up with that. Origin is USQL early 2000s. It faced the problems that SQL had, like the fact that it just took so long to compute, and like it was using outdated software and overpriced software. Most companies today implement new SQL, and they start on a small scale because it takes a little bit of a while to come up with the right formula to um, become like dependent and like rely on and trust in your formula. Since you know the SQL, you kind of have to make up your own for whatever you want. It takes a while to get that dependability, and it gets more and more widely used. It's an open source, purely open source um, program, and eventually more and more people are going to start using it as they are right now, and um, we'll see people deal with the problems right now. I guess one of the problems that's kind of a benefit too is it's solely open source. It takes a long time to develop consistency. And if we go back, you can see there's a lot of different um, new SQL programs out there to use. And there's just a lot, so it takes a while to find the right one for you. Future of both new SQL and relational database model. New SQL is replacing the no SQL because it's handling all the new information. As you can see on like the right, structured data takes up tiny bit. Most of it's like all the new information that was made after 2000, like blogs and tweets and Facebook and all of that. So SQL is kind of becoming outdated, and it's programs like struggling to keep up with all the new data that's being presented out there. Um, they're both still useful, and they're both still widely used. Related database management system is still used in finance and accounting in companies where they're not dealing with um, oh, excuse me, sorry, they're not dealing with um, data from Facebook or like Twitter or anything like that. They're dealing with raw data, dealing with data they've always been dealing with. And of course, like new data comes in every day, and there's always like use for new data, but they don't. Essentially, they just use that like stable instructional data. And then USQL is also used for like companies like Snapchat and Twitter and Facebook, like where they need those the patterns in human behavior to structure their company around. So basically, what we talked about today was what databases are, what database management is, and the need for innovation in database management. We talked about NoSQL and new SQL, or no, sorry, SQL from the relation database management system, and new SQL from the NoSQL theory. And as you see right here, just what a database is and all the studies about it, and like what's going on to try and create maybe like a blend of both. There's a lot of companies are doing, and then we're gonna see the future of database management and see if NoSQL eventually replaces relational database management. Okay. My name is Steven Sullivan, and here are my sources for all the information I looked up about um, databases and database management and what SQL is and all that fun stuff. All right. Thank you. Bye.